Welcome back. Here I have the data and the R code already open. The data file shows the coded variables x1 and x2, the natural variables time and temperature, and our response y, the yield. Let's start by loading the RSM library. We are going to start our analysis by running the str function to check the file structure. We can see that all the variables are numeric, so we are good to go ahead with the analysis. The next step is to assign the relationship between the coded and the natural variables. We are going to assign x1 and x2 as coded data by using the relationship between x1 and time and x2 and temperature that we have seen in the previous video. Now the file structure shows not only the variables in the data file, but also the relationship between x1 and time and x2 and temperature. The next step is to run the regression model for a first-order model plus the interaction. The results are pretty disappointing. Not x1 or x2, neither the interaction between them was significant. The R squared is extremely low, the p-value shows the regression is not significant, and the lack of fit was significant. Let's take a look at the results and try to understand what is happening. We can see that the effect of the time is 2.5% at 180 degrees and 1.5% at 170 degrees. Regarding the temperature, its effect is 0.5% at 80 minutes and 1.5% at 90 minutes. However, the intrinsic variation among the replicates at the central point is 0.6%. The effect of time and temperature seems to be higher than the intrinsic error. Then, why are they not significant? The answer is in the lack of fit. The linear model with interaction is not adequate to describe the behavior of the data. We can also see the nonlinear behavior when plotting the experimental results against the regression variables time and temperature. The behavior clearly follows a second-order model. The quadratic model with interaction for two factors has 6 regression parameters. However, our design has only 5 independent runs, since the replicates are not independent runs. We need at least one independent run for each regression parameter. The 2 in the power of k design with central points can check the model linearity, but cannot estimate the quadratic parameters. So in the next lessons, we are going to see an experimental design to fit second-order models.